I'm Craig Gresbrink, Solutions Architect at 24 Hour Fitness, and I've been there for about 10 years as the Solution Architect, 20 years prior to that. And I've been the Ignite product owner at 24 Hour Fitness for about 3.5 years now. First, a little bit about 24 Hour Fitness and who we are. We operate 280 plus health clubs coast to coast, and we've been doing that for over 35 years. What we're going to talk about today is Ignite as an integration platform for other vendor or SaaS or cloud systems. And we're going to see some of the limitations you might find in those systems and how Ignite can help. And then you'll get a little intro into our architecture, and then we'll talk about how Ignite helped us through a difficult time at 24 Hour Fitness last year. The first thing, we implemented a few systems like this, a CRM system, and there's previous presentations I've done at the summits before that can discuss that in more detail. But the system I wanted to talk about in this presentation is we had an on-prem ERP billing system, and we replaced that with a SaaS billing system. And it would have been nice if we could have just integrated this way. On the top left, you'll see the applications, our sales app, club check-in. And then we have an ESB that can call web services. And the idea would be we just call the SaaS billing systems web services. We don't store any data on-prem. We can do everything we need to do. The problems with this are a lot of vendor or SaaS solutions have API rate limits to protect their systems. And this SaaS billing system also has API rate limits. And we have 280 plus clubs, like I mentioned, and we check in people. And we need to find out things like referenced in 2.1 is, do you owe us money? Like, should we let you in the club? Do we need to ask you for money? So every club check-in, we're wanting to answer that question for each customer that checks into our clubs. And then other things we do on our member services apps is we like to search up our members by first name and last name, 3.1 down there. And we want to do it with a like clause, a partial name and a partial first name and last name. And the API rate limit, the API capabilities of our SaaS billing system just didn't allow for that. So here's what we ended up building to solve this problem. We'll start on the top right, the SaaS billing system, and then a cache loader on the bottom right. The billing system has ways to get Delta data or any data that's changed in the last 15 minutes. So we do that, and we create files, and then we ingest those into Ignite, doing JCache puts, and that gets it into our Ignite data grid, or I might call it the cache, I might call it the grid, I might call it Ignite, all the same things. And once we have the data in there, our applications, like in 2.1 and 3.1, we query the Ignite data grid and get great performance. We don't use up our API rate limits, and like in 3.1, Ignite SQL enabled, so we can do the like clauses that we want to do to search up members. And then you'll see 1.1 there. Our billing system is still our system of record. So we do, when we make a sale in our sales app, we do create the subscription and the account in the billing system because it's our system of record, and then it flows through into the grid. So that's how we used Ignite to solve the limitations of the SaaS billing system's API rate limits and lack of capability. I also wanted to give you a little bit of a high level of how our architecture works. You'll see the top right, the billing system. We just talked about that, the cache loader, nothing new there. On the top left, you'll see a CIAM system, or Customer Identity and Access Management System. It's also a SaaS system. It happens to do webhooks when data changes. And so we expose web services that they call, and the data flows into the grid that way. What we really have here and showing is it's a converged database, the Ignite cluster, because we're putting data from multiple SaaS systems and even multiple, like our member check-in system, homegrown systems. All the data is in one data source, namely the Ignite cluster. Other ways we use the grid, on the bottom right, our QA team has automation scripts that we run in non-prod, and they query the grid with JDBC to gather up data to run those tests in any given environment. And then we use the Ignite web console a fair amount to run ad hoc queries, and we'll talk more about that. And we also monitor the grid, and we'll look for long-running queries and such. And then in my presentation at 2:15 today, we'll get in a lot of detail on continuous queries. So please join that if you want to learn more about service grid and continuous queries. And then for us, we're event driven. So we often put events on JMS and consume them with our ESB and update various systems. I wanted to talk about another limitation that our SaaS billing system has, and you can see it on the top right in that data query, the 1 million number that you see for the number of records processed. That means the driving table of your queries, if you were to query our SaaS billing system directly, can't be more than 1 million rows. And we have over, let's say, over 2 million members or customers. And so running queries against our whole customer base would fail in our SaaS billing system because of this limitation. Also, you'll see in the use case, the COVID-19 use case I'm going to discuss in a minute, the maximum number of output records is 500,000. And in certain cases, to stop billing, we needed to return CSV files or result sets that were more than 500,000. And so those limitations caused us to elsewhere and see how Ignite could help us. I kind of alluded to it, but back in March, 24 Hour Fitness had to close all of our clubs nationwide. Never thought we'd ever do that. I've been here 20 plus years, and it was an interesting time. We're not the only business, obviously. It was a disruptive time. That meant we had to turn off billing for all of our customers and also suspend their accounts. And throughout it, we started reopening clubs. We restarted the billing for certain clubs, and then we had to reclose clubs and then ultimately reopen those clubs. So I'm going to talk, how did Ignite help us? I mentioned the limitations that we had in our SaaS billing system. So I'm showing you just one query. We probably had about 15 of these of various types of things we had to do. But this one is basically looking and joining about 6 caches, account, subscription, rate plan. These are all caches or tables in our grid. And it's joining them, trying to find who has personal training so we can adjust their billing in our billing system appropriately, so we charge them correctly given the situation we found ourselves closing and reopening clubs. Again, notice in this query, it's not by member number or account number or anything like that. This is aggregate across our whole customer base or account base, which is over 1 million. As I mentioned, or as you can see on the bottom, I guess I didn't mention it, we do use Ignite's web console, and this is an ad hoc query, or a query ran because of COVID-19 billing changes we had to make. We ran it in Ignite's web console, and then we generated or exported CSV files, and we gave those to the billing team, who then ingested those into our SaaS billing system to do, I guess you'd call, mass update to adjust billing. And again, that flowed back through to our data group. Please consider joining consider attending the show or my presentation at 2:15 or 2:50, sorry, because I'll get into more details. This is pretty high level, but essentially we use Ignite as an integration platform to solve a lot of our vendor limitations. It would be ideal if we didn't have to put the data on-prem, but as I've shown, there are advantages and sometimes unforeseen advantages to having all of your data in a converged database that you can query. So you can get around things, the API rate limits, maybe lack of functionality, like customer search was an example. And then in previous presentations, I talked about some of our vendor systems having performance and scalability issues. Their APIs took more than 250 milliseconds, and we had to call multiple of them. And now to save a lead, it would take over a second. With the grid, we return queries in 20 milliseconds or less. And again, as I was saying, the unforeseen circumstances that we found ourselves adjusting our billing system, Ignite really helped us by having all of that data in one spot that we could query on an ad hoc basis. In some cases, I only had a couple hours to personally run those queries and provide that data to the billing specialists so they could update our system to make sure we build appropriately. So again, yeah, here's what I'm going to be talking about. I've alluded to it a couple times, but at 250 today, I keep saying 250 today, I'm going to go into a lot of details about how we use the continuous query, how it works, what our use cases are, some limitations of continuous query. It's kind of like a database trigger, you can think of it that way. And then we'll talk about service grid and why we had to do that, how it works, and how we used it to solve one of those limitations. And then at 24-hour fitness, we use Ignite native persistence or Ignite persistence. And so I'll talk a little bit about how that works and the benefits we found with Ignite native persistence. And then how we use the grid as a system of record for certain caches, meaning the data does not exist anywhere else. Like in our SaaS billing example, the data does exist elsewhere, namely the SaaS billing system. In some cases, the Ignite data grid is the only place where that data exists. So we're really using it as an in-memory database. And I want to thank you, and I'll point to, if you want the full 24-hour fitness story and how we envisioned this and some of the struggles we had and SQL tuning and such, I'll reference some previous presentations I did in 2017 and 2019. That'll give you sort of the full story of some of the details I alluded to in this presentation. So thank you very much for spending your time.